Hi everyone. Today we will learn how to use LCD with I2C protocol with Raspberry Pi Pico. These are the required components. First, Raspberry Pi Pico, and then 4 jumper wires and 16 columns with 2 rows LCD using I2C protocol. This is the LCD hardware. At the back of it, we can see 4 connectors. Here are the 4 connectors marked with ground, VCC, SDA, and SCL pin. That LCD will connect into also 4 pins on Raspberry Pi Pico. I make a slight modification here. Here I make jumper from V-bus pin. This one. 2 positive line here. So along this positive line we will have 5-volt power source. We also connect this pin here into this line. So we will also have ground along this line. We will connect LCD VCC to this line and ground to this line, and we will connect SDA pin here into the first pin here because it can be used as SDA pin, and we will connect SCL pin here into the second pin because this one GPIO1 can be used as SCL pin. We will need 4 wires for the purpose. We can see here the yellow cable connected to SDA pin, green cable connected to SCL pin, red wire connected to 5-volt, and orange wire connected to ground. From LCD side, we can see here ground connected to orange wire, VCC connected to red wire, SDA into yellow wire, and SCL into green wire. Besides the hardware, we also require some software. First of required software is Pico I2C LCD. We could get it from here. And then LCD API, we could get it from here. The link will be on the description of this video. Here are the 2 software required. The first one, Pico I2C LCD. We will copy this. Control A to select all, then copy. Go to Sony IDE. First connect the board. Then reset the board. We will create a new file here. Paste the code. And save it into Pico I2C LCD.py file. Save into Raspberry Pi Pico. File name is here. And then the second file we need is LCD API.py. Select all, copy, then paste into new file on Sony IDE. Paste here. Save this file as LCD API.py. So we will have 2 files here in our Raspberry Pi Pico. We could close this one and also this one, and we will create another file for our program. After we have those two files, then we could start our code. From machine, import I2C, import uTime, then from Pico I2C LCD, import I2C LCD. Please remember that everything on Python is case sensitive. Then now we will initiate the I2C. I2C address is 0x27. I2C number of rows 2, because we used 2 rows LCD here. I2C number of columns is 16. 16 columns to 2 rows. Then we will initiate the I2C object. ID is 0, then SDA is pin 0, SCL is pin 1, GP0 and GP1. Remember that we will use this GP0 for SDA and GP1 for SCL pin. Then we will also initiate LCD object, I2C LCD, I2C, I2C address, I2C number of rows, I2C number of columns. Then after that we can start putting some string into our LCD. Create new line. We could try to run this code. We will save it as main.py. We can see that this code is running as expected. Then we can add another code here. We want it to show for 2 seconds. Then after that I want to clear the LCD. We can call a clear method. Then put another string there. We want to try to create the loop here, just counting the number. Now we will enter the loop. We will try to count the number below 20. We will use move to method here to move the cursor into the desired location. 0.1 means it will move into column number 0 or first column, and row number 1 or second row. We want to clear that line. Print empty string, 16 character here. Then we'll increment I value here, +1. Move again cursor to column 1, row number 2. Then I will put the number here. I use the modulus operator here, so the number will not reach 20, actually from 0 to 19. Then sleep for 1 second. Try to run this code again. This number is growing, but will not reach 20 because we use modulus 20 here. That's it for today. Thanks for watching.